All right, everyone. Today we are going to discuss some very nice questions from the chapter of projectile motion, which are advanced level at least. So these are very relevant questions for JEE Advanced. So these include multi concepts and they are also asking for algebraic manipulation. So without any further ado, let's get started. So the first question says the radius of front and rear wheels of a carriage are A and B. Right. This is A. This is B. This is what is given to us. Then C is the distance between their front and rear axes. So we know the axles are mounted at the center of circles. So we just write that. A particle of dust driven from the highest point of the rear wheel is observed to alight on the highest point of the front wheel. Okay, so we did draw it right. Right, so we did draw it right because if we had drawn it this circle smaller, then what would have happened? It wouldn't have been possible. So this needs to be bigger than this, right? So what we are working with right now is right. So we need to figure out the velocity of the carriage, right? But it is projected by some velocity. So the very crucial concept now is most of the students will just assume that the velocity of carriage is going to be the velocity it is being projected by, but that is not the case. It is going to be 2v instead. So this is a very core concept of rotational plus translational mechanics. uh, when the center of mass is moving by velocity v, let's say, so all points are moving by velocity v, but when rotational motion also occurring, so it provides it an additional velocity in cases of in these types of cases. So what happens is the topmost point often ends up having the velocity 2v instead of v, right? So this is what we are going to work with right now. Let's just label it v naught because I do not want to get confused, and we'll finally substitute it that v naught upon 2 is going to be our answer, right? So we are just going to get started now. So right, this distance was c. We need to keep in mind that it is not totally horizontal and it is actually slanted at some angle, a very small angle in this case. So let's get started with it. First, we need to analyze how this velocity is provided. So it is provided totally level with the ground. It is going to be totally horizontal. So the projectile motion is going to be somewhat like this. Now, the way we can judge it is by v naught multiplied by t is equals to the total horizontal distance between them. Most students will make this mistake of considering c as the total distance, but that is not the case. The distance is going to be somewhat like this. So how can we give this? We get this by b minus a. This is b and this is a. So we just subtract them and then we get the value of this part. So we can give this expression by c squared minus the perpendicular. So it is b square. Oh no, b minus a whole squared. So this is the expression that we are getting. Now we need to figure out the time for it. So the time for it is very easy to figure out. The initial velocity is 0 and the total height it travels is what is it? Okay, it's going to be 2b minus 2a because this is the total diameter and this is the total diameter, so this is the distance we are calculating. So the total height it travels is 2b minus a. Initial velocity is 0 and the acceleration is going to be g by 2 t squared. So it becomes 4b minus a upon g whole square, oh, whole under root. This is going to be expression for our time. Now let's see what we are working with. So we need to multiply it by v naught to get it equal to the expression c. We can write it as c plus b minus a and c minus b minus a. This is what we can rephrase it as, right? Just put the G here. So it is going to end up in the divisor now. Just put up a whole root and we have this expression with us. C plus B minus A. This is C minus B, C upon 4 B minus A. So this is the expression that we are getting. Now we just need to divide it by 2 and then we'll get the answer. Let's move on to the next question. So I got the options for it myself. So two particles, two particles are projected from a point at the same instant with velocities whose horizontal and vertical components are u1 v1 and u2 v2. You could also write it as u1 cos theta 1 or something, but I just chose to not write it as that. Now we need to figure out the interval between their passing through the other common point of their path. Okay, so what we need to figure out is t1 minus t2, right? This is what we need to figure out. Okay, assuming that this particle reaches that point first. So it is just an assumption, but we can just move ahead with the solution. So the graph looks something like this. You need to figure this out. Now there are many ways to do it, but the most optimum approach in my opinion is going to be using the coordinate system. So let's just use the x coordinate and y coordinates, right? So the expressions for x coordinate are equal, so it is going to be u1 t1 equals u2 t2. Okay, so the y coordinates are also equal. How can we express it again? We can express it as, okay, yeah, v1 t1 minus g upon 2 t1 squared equals v2 t2 minus g upon 2 t2 squared, right? This is the y coordinates. So these both of them are equal. Now what we need to figure out is t1 minus t2 from it. So after a bit of looking, you can observe that this can be easily broken down into an identity. So what we can do is we can just take it in a common side, right? Let's just take it this way, because the answers are given v1 minus v2 form. So v1 t1 minus v2 t2 plus gt2 square upon 2 and minus t1 squared. So from this point we can easily figure out what we need to figure out. So it is going to be t2 minus t1 and t2 plus t1. You can break it down into this pieces. Now what we could have done better was we could have just kept it at this side and write it as this expression. Then we get t1 minus t2 and t1 plus t2, and we put it up here and we get v1 t1 minus v2 t2 upon g, and it is accompanied by t1 plus t2. We already have the ratios of t1 and t2 in terms of u1 and u2, right? So we can write t1 as u2 upon u1 t2. Okay, so let's just move ahead with that. When we try to substitute these values, we get, okay, v1 u2 upon u1 t1 minus v2 u1 t1 and whole accompanied by this outside, and then t1 plus t2 would become u2 upon u1 t2 plus u1 t2, right? This is what it becomes. Sorry, this is going to be t2 and this is going to be t2 as well. I'm really sorry for that. So now we have it in these terms. You can easily see we can cancel out the T2 from everywhere. We can cancel out the U1. And let's check the answers now. U1 plus U2. Okay, so the denominators need to be positive. This, and it is V1. Okay, so this appears to be the right answer. If I have not made any calculation mistakes, you can just check it yourself. Now the final question that we are going to deal with is, a stone is projected from the point of ground in such a direction so that as to hit a bird on top of a telegraph post of height h. Then attain maximum. Okay, so it looks like something like this. It looks something like this. This is h and this is 2h, let's say. Okay, let's just write a bit here. And then this is h again. And the bird travels on this lane, right? It travels with a uniform velocity. Find the ratio between horizontal velocities of the bird and the stone. Okay, if the stone still hits the bird while descending, right? So we have to figure out the velocities ratio. Okay, so let's get started with the question without any further ado. Let's first solve for h because we will get two values of h. So let's just solve for that first. So h equals u sine theta t minus gt square upon 2, right? This is what we get. So let's solve it as a quadratic in terms of t, right? So t can be written as, how can we write it as g? Okay, so let's place it g here. Then we have u sine theta. Then we have plus minus under root. Then what we get is u sine. Okay, so it's gonna be u square sine square theta minus. Oh, what's it's h 2 g. So it's gonna be 4gh upon 2 becomes 2 instead, right? This is what we are going to deal with, right? Just give me a second. Let me recheck my calculations once. Oopsie. Oopsie. Let me just rewrite it once again. So the equation was 1 by 2 gt squared minus u sine theta plus ah equals 0, right? So solving gives us g upon u sine theta plus minus under root. How do we proceed with this? Okay, this seems very tacky. Yeah. Okay. I think I got it. So we know that this is the maximum height that it reaches. So u sine theta can just be written as root 4 gh, right? So it becomes root 4 gh and it becomes 4 gh minus, okay, 4 into 2 2gh, okay, minus 2 gh. So this is what it becomes basically. Now when we proceed with this, we get 4gh upon g plus minus root 2 gh upon g. So we just put a root here and take this stuff out, right? So this is what we are left to work with in this scenario. So let's just figure out this. Let's assign the negative sign value to t1 and positive sign value to t2. Okay, so vt2 vt2 can be given to be equal to u cos theta t2 minus t1. Wait, was projected from. Ha, okay. Yes, yes, yes. We are having the right expression in this scenario. So we can just figure out the ratio from here. So it becomes v upon u cos theta equals t2 minus t1 upon t2. Now if we try to simplify it, what do we get? T2 is root 4h. Okay, so we get root 2h extra upon root g, and then t2 itself is root 48. Okay, so okay. I think I figured it out. Is it? I think it's going to be somewhat like this. I'm really bad at calculation, so you can just confirm my answer later on. But I think this is going to be the solution. Uh, if you have any doubts, just post them below. And I think it was a very fruitful session. Thank you for joining in and subscribe for more. Bye.